this now. This is your format, where A is the amplitude, B is the frequency, and the period is 2 pi over B. Or if you need to, think 360 over B. Okay, it works the same for all of them. These guys right in front, amplitude. That's going to change the height of this. That's going to give you a vertical stretch or a vertical shrink. Okay, your amplitude, vertical stretch, or shrink. Okay. Your frequency, not on this part. This is just your amplitude. So we're looking at your amplitudes. Your frequency did not change. You had one curve in 2 pi. So this guy first started out with your regular curve. This was in red. This one here is in red. Oh, no, sorry. I'm safe. It's in blue. This guy is here in blue. Up to the 1, down to the -1. Full cycle. 0, 1, 0, -1, 0. Full cycle. Okay? Now, you changed your amplitude to 0.5. Take all of these guys, easiest way, multiply them by 0.5. So 0, 0.5, 0, -0.5, 0. That's the red guy. Easiest way to do that. Just take your cycle and multiply it by the amplitude. Then the green says amp it by 3. Take all these guys, multiply it by 3. 0, 3, 0, -3, 0. Here's your green. Find it?
I'm looking for it.
That's okay, neither did they, because they didn't do it either. It was on for 2 days?
Yeah.
Here's the one we're doing right now. And that's the one we're working on now. This is the one we're working on right now. Okay. Same thing with this guy. Everybody okay with the amplitude? Just your amplitude change. Nothing else. So, in this one, here's your basic cosine curve in the blue. This is a 1. Guys, I need it quiet. We increased it to a 2. 2, 0, -2, 0, 2. Okay, we went to a 0.3. Yeah, kind of estimate the 0.3. The 0.3 is a little less than a half, so 0.3, 0, -0.3, 0, 0.3. You're sketching, so nothing is at that exact. It's a sketch. Okay, if you didn't have different colors, just a good thing to do at the end of this one is just to label this. God bless you. Just label it so that you know which one is which. Or maybe do a dotted line. A light dotted line and a dark dotted line. Something that you can tell the difference between them. The harder one was changing your frequency. Oh. Was everybody able to fill in this chart? Your period stayed the same. Well, 2 pi over 1. It's 2 pi, well, this is your frequency over here, 1. That's big. That means you completed 1 curve in 2 pi. The period is this, 2 pi over B. They're all 2 pi over 1. We did not change the frequency on the first set. We just changed the amplitude. I like this worksheet because first it changed the amplitude, then it changed the frequency, then it combined it. So it let you see the changes for each one. And it also gave you a calculator step on how to do this. Okay, here's your frequency changing. This is B. I now have a frequency of 3. That means I need to put 3 curves in 2 pi. I don't know why they do this, but just keep, this is your frequency. You don't have to do that. I don't know why they do that. I don't do that either. I just go like this. They're just saying, what they're trying to tell you is 1 curve in 2 pi. They don't mean 1 divided by 2 pi. Half a curve in 2 pi. That's what they're trying to say, but it's not divided by. And your period, remember, is 2 pi over b. If it helps you, say 360 over b. So the first one, basic sine curve. Here was your blue. Basic sine curve. And it's good to do the parent graph first. Then we did 3 curves in 2 pi. So if 3 curves are in 360, how much for each curve? 120. 360 divided by 3 is 120. I need to complete 1 curve in 120, 1 curve in 120, 1 curve in the third 120. Each curve goes around 4 quadrants. So if I take 120 divided by 4, how big are the quadrants? 30. So again, here's your 90. You're going to get 3 sections within all of these. This is the easiest way to do this. Block it off here at the 120. There's your 120. See your curve ends right here? Here's your red curve, ends at 120. Another 120. Another 120. See it? You did not change the frequency. You did not change the amplitude, just the frequency. Don't worry about it, guys. Don't worry about it. And the last one, you had half of a curve in 2 pi. So your sine curve goes like this. You only can put this piece, half of this curve, spread out to 2 pi. It kind of makes sense that half of 2 pi is 180. So just put the 1 point up here. You're only putting half of your curve in a full window now. Can we all sketch these? Okay. We're not asking you for exact. I don't want to see all the little angles in between. You need your mins, your maxes, and your zeros, which is why we follow your pattern of 0, 1, 0, negative 1, 0. We follow that pattern, mins, maxes, and zeros. We don't need the guys in between. Okay, this did the same thing, but it did it for the cosine curve. So your basic cosine curve had a 1, then you put 2. If your frequency is equal to 2, your period, God bless you, is 2 pi over 2, or 360 over 2, 180. At the 180, cut it off, and then make 4 quadrants. Section it off. Half, half. There's your red one. Say it. 2 of them in 360. 2 of them in 2 pi. And the last one was a half a curve. See the green, do your half a curve? Try not to make that half a curve a straight line, because that cosine curve, when it stretches out, it tends to look like a straight line, but do you see the curve in it a little bit? It's really not a straight line, it's a little bit of a curve. My curves really are not the best either, but my peaks are not the greatest. But I'm writing sideways, that's my excuse, without trying to stand in front of you. So your period, if you need to convert to degrees, think degrees, because that will help you separate it into 4 quadrants. Every cycle takes 4 quadrants. That's key to this. Even though you find your period, each cycle goes through 4 quadrants. So whatever your period is, you're going to divide your period by 4. That's what's going to help you graph this. So if my period is, if I'm doing half of my curve in 2 pi, think about it. If it takes half for 2 pi, it's going to take another 2 pi to make 1 complete cycle. So my full cycle is 4 pi. Divide that by 4, there's my every 180 degrees, every pi. Are you okay with graphing with the radians? Anybody have a hard time keeping the graph in radians? Okay. And then the last one had you do 2 at the same time. An amplitude change, you changed your amplitude to 1/2, and you had your frequency of 3. So your cosine curve goes like this. Multiply everything by 0.5. That's your cycle. You see them go at the 0.5, the 0, negative 0.5, the 0, the 0.5. That's 1. You have to pick 3 of these. Again, so 360 divided by 3 gives you every 120. If you could kind of eyeball this, that's fine. I have a hard time eyeballing. I can get my first 120, but it's my second 120. I got to convert it anyway. So if you say 120 is your period, divide that by 4 and just section these every 30 degrees. I think that's far easier to do. Section it by every 30 degrees. And then you can count 30, 60, 90, 120. There's 1. 30, 60, 90, 120. There's 2. 30, 60, 90, 120. There's your last one. Do you see them fit inside? It's the same if you do this in your calculator. If you put this in your calculator, which is fine, the problem is, unless you change your delta table to 30 degrees, you're not going to see all the parts. So you have to remember, your delta table, changing your increments, is always the period divided by 4. That's what helps us see all the parts. Otherwise, you're not going to see all the sections. This last guy did half of your sine curve. This was nice, and it amped it to 2. Good? Do you have questions on this? This is going to try to find the equation given a curve. So first and there's no phase shifts in these, otherwise they would be impossible for you to decide what it was. Is this going to be a cosine curve or a sine curve? Cosine. So we know this is going to look in this form. Start like this. And you can do plus or minus, whatever you have to do for the phase shift. A is your amplitude. B is your frequency. Now, because this curve has shifted off of your x-axis, find your resting point. So take the top one. So this is 1, 2, 3, 4, 5. And the bottom one, it spans 6. So what's half of 6? 3. So come down 3. Here's my resting point. Easiest way. This moved up here. See it? Okay, so let's figure this out. What's the amplitude? What's A? This is my resting point, right here. From here to here. 3. Okay. Did I reflect at all? My cosine starts at the top, right? Okay, so far so good. I need to find B. Here's 2 pi. How many complete curves are from 0 to 2 pi? 1. Good. So your B is 1. So now all you have to do is put this together. But we need one more. We need a shift, and we'll put this in at the end. 3 cosine 1. I don't have to put the 1 in here, but if you want to, you can. And this shifted. How far did this shift up off the x-axis? 2. This is your plus 2. Your shift goes at the end. That's the difference between here and here. Find your resting point. It's the easiest way to do this, because what happens is your amplitude is changing. If you try to just go by your amplitude, it's an amplitude change of 3, not a shift of 3. So find your amplitude, find your resting point. Your resting point goes from your x-axis to down, up, wherever. That's where your shift is. So now we have the equation of your graph. Good? All right, I want you guys to try the next one. Try the next one and see what you come up with. So, where's your resting point? At y equals what? -2? Let's see. We have 1, 2, 3 up. We have 1, 2, 3 down. Perfect. This axis has a vertical shift down 2. That's your vertical. What's your A? What's your amplitude? 3. From the resting point to the top or the bottom of the curve. They're both the same. Remember, your amplitude is always positive. Amber? The resting point. Take the top to the bottom. Count, just easiest way, count how many spaces. 1, 2, 3, 4, 5, 6. Divide 6 in half. So 3 on the top of it, 3 on the bottom of it. Just count down 3. And there's your resting point. The difference between the max and the min is 6 units. So halfway, each one has to be 3 up and down. That's the amplitude part, 3. So if you count up or down, maybe count up this way, that might look easier. That's your resting point. That shows us the vertical shift from your x-axis to that axis. So amplitude is 3. Now we got to find your frequency. Find 2 pi. How many complete cycles in 2 pi? 2. Sorry, 2 pi is here. 2. 1. 2. Okay. Down. It still looks a little bit weird because usually cosine goes up instead of down. What caused that? Negative. This was a reflection in the x-axis. This is where the negative comes from. So let's put this together. Negative 3 cosine 2x. And where's my shift? Down 2. Minus 2. Yes? These 2? Because you have 2 complete cycles. Here's your 2 pi. So trace this. Here's 1 cycle. Here's 2 cycles. B tells me how many complete cycles in 2 pi. My period tells me 2 pi divided by 2. Every 180, I made 1 cycle. Okay? But the B is the one that goes in your equation.